In the midst of dry land, where water is scarce, Mount Kenya rises to 5,200 meters above sea level. In these vast surroundings, the mountain provides the essential lifeline, water. Mount Kenya captures rainfall that nourishes rivers and brings life to the otherwise very dry lowlands. The mountain and the surrounding lowlands are inseparably linked. The link is water. Here, 80% of people make their living from agriculture and cattle raising. Their survival and economic prosperity depends on highly erratic rains. While some rainy seasons may be plentiful, others fail altogether. With rain so unreliable, farmers see irrigation as the solution. Even if irrigation sometimes fails, it remains a dream shared by many people northwest of Mount Kenya, an area with more than 500,000 inhabitants. This dream is fragile. More and more water is being diverted onto fields and plantations through small channels. This water abstraction drains the rivers, and while more people rely on river water, that very source of their livelihood is reduced to a fraction of normal flows.
Laikipia district is a settlement area, so we still have many people coming in, so that there is this conflict of everybody complaining about water. There is a lot of tension between the different water users, because this is survival, and each one wants to survive.
In 1984, a joint Kenyan-Swiss research project based in Nanyuki at the foot of Mount Kenya was initiated to help provide better water management.
So one of the main goals of our research intervention was to try and build a knowledge base that people could use, first of all, to develop a better understanding of the variability of rainfall in different places in this area, and see how they could optimize the use of these scarce rainwater resources.
The first step towards knowledge is understanding long-term weather patterns. In collaboration with the Ministry of Water Development, the research project maintained a total of over 50 old and newly established weather stations to gather the necessary data. The stations cover an area of more than 15,000 square kilometers northwest of Mount Kenya. Measurements are also taken along the rivers. The data cover several decades and thus reveal long-term trends. The weather stations and the river measurements constitute one of the densest measuring networks in Africa. Postgraduate students and researchers analyze the data and develop results and conclusions. This process builds up research capacity to analyze problems and seek solutions.
Research has contributed to provide a database where we know how much rainfall we have in the area, how much water there is in the river from up the mountain till to the lowlands, and very important, how much water is being used and where and how it is being used. So we have been able to build up a database that helps, provides the basis to understand why do we have a problem, how big is the problem, or what kind of solutions we can find for it.
Research has shown that as a result of water loss by evaporation and runoff, often less than 1/3 of the rainfall is used for crop and fodder production. How can land users reduce this loss? This farmer uses rainwater very efficiently. He has protected his land with strips of Napier grass. This conservation measure is well adapted to his needs. Every drop of precious rainwater can be used in the most efficient way. Erosion and evaporation are greatly reduced. the farmer benefits directly in terms of increased production and food security. At the same time, he covers the soil with cut-off plant residues and branches called mulch. Mulching, combined with minimum cultivation of the land, has proven to be very effective against water loss and soil erosion, and has resulted in increased yields. During heavy rains, up to 2/3 of the rainfall is lost because it runs off the land, especially when land is overgrazed and degraded. Can this excess water be stored and eventually be used in the dry season? Measurements are rather difficult, but they reveal the great potential for capturing floodwater. A number of small dams illustrate the potential for water storage and harvesting. Some irrigators in the upper region of Mount Kenya have realized that in the longer run, they need to retain excess water and use it during the dry periods when scarce river water should be left for people downstream. In the Mount Kenya region, many urgent problems need to be solved today. What are the consequences for tomorrow? How will daily decisions increase or reduce water conflicts? Computer models are tools that have been adapted and used to answer these questions. One model illustrates that better land management increases the availability of water dramatically. If all farmers protected their land with measures such as mulching, grass strips, or agroforestry, direct runoff during storms would fall to less than 1/5 of the current level. This implies that much more water would remain in the catchments to be used by the farmers. Models also support decision-making for the whole region and foster regional perspectives. They help to identify priorities and limitations for more water development. Models and other research tools have been used to compile a regional water development plan. This is needed to assess water resources, allocate them at the regional level across district boundaries, and set priorities.
To some great extent, we have seen, where possible, the government taking up our recommendations, implementing them, and witnessing change taking place in the water sector.
Local, national, and international efforts are needed in the search for solutions. Only through the joint efforts of land and water users, development projects, and research teams can solutions be found that allow mountains to maintain their role as water towers and provide a livelihood for people both in the mountains and in the surrounding lowlands.